Okay, going through the further maths paper decision 1. This is from the March 2022 mocks. Okay, so this paper has a separate question and answer booklet, so I'll be flicking between the two papers. Okay, apologies for that in advance. Okay, right, question number 1. The table below shows the lengths in kilometres of the roads in a network connecting 7 towns, A, B, C, D, E, F and G. By adding the arcs from vertex D along with their weights, complete the drawing of the network on diagram 1 in the answer booklet. Okay, so here's my answer booklet, and we can see we've got a copy of the table, and we have our network without the arcs connected to D. So I'll add the arcs in to this network. So just looking at the D row, D connects to A with a length of 22. D connects to B with a length of 27. D connects to C with a length of 33. And D connects to F with a length of 42. And that's it. The column's got the same number, so you could work down the column instead. There's no one-way arcs in this table. It's a symmetrical table along the non-lead diagonal, so no arrows on any of those. Perfect. Okay, so that was 2 marks. Part B. Use Kruskal's algorithm to find a minimum spanning tree for the network. You should list the arcs in the order that you consider them. In each case, state whether you are adding the arc to your minimum spanning tree. And then part C, state the weight of your minimum spanning tree. Okay, so Kruskal's algorithm, this is the greedy one. This is the one that keeps looking at the whole network and keeps selecting the shortest arcs such that no cycles are created. So looking at the whole network, we can see that the 22 is the smallest number. So therefore AD is the one I'm going to choose first, and that's the length of 22. Then we're going to have an AB, which is 24. Then we've got BC, which is 25, so there's still no cycles, that's fine. There's no 26s. We've got a 27, but that's going to create a cycle here, so we don't want that. But I do need to put it down. So BD, put 27. I'm just going to put a big cross here just to indicate that I'm not selecting it. Okay, add the 27. Oh no, 26 needs to go in there. In there we have CG, which is 26. Apologies, I missed that one off. So we've now got this one, this one, this one, and this one. We've rejected that one. There's only one left of the 20s, that's 29. So that's DF, which is 29. So we're selecting that one. Oh, it's 42, come on, pay attention. That one's 29, which is EG. Okay, and now it's just F that's not connected. So the next shortest is the 31, which would get rejected because that would create a cycle around CGE. So CE, which is 31, gets rejected. The next shortest is then 35. AE, again, that will get rejected because of this cycle around here. So AE, 35 gets rejected, and CF gets accepted at 36. Okay. So reject EF. Yeah, and then you could reject the others, but because that is now 1, 2, 3, 4, 5, 6 arcs that have been chosen, we can actually stop the algorithm at that point because there are 7 nodes, and a tree by definition has n-1 arcs. So we don't have to worry about carrying on the algorithm. Okay, so we can actually stop there. Okay, so the total length of that tree is just the sum of these arcs. So 22 plus 24 plus 25 plus 26 plus 29 plus 36. 1, 2, 3, 4, 5, 6 numbers, that's 162. Okay, so that was 6 marks. Okay, question number 2. All right. So here we have figure 1 represents a network of corridors in a building. The number on each arc represents the length in meters of the corresponding corridor. Use Dijkstra's algorithm to find the shortest path from A to D, stating the path and its length. Okay, that's easy. So starting from A to D. Okay, so we're going to start at A and we're going to stop when we get to D because we want to find the shortest route from A to D. Okay, so we have Dijkstra's algorithm ready to go on this table, and you've got a little reminder down here of what each box represents. So we start at A, so that's the first order of labeling, and that is a total of 0 distance from A itself. So we update the adjacent ones, so that's a distance of 38, that's a 75, that's a 42. We now choose the smallest of these, which is 38. So that gets labelled with a 2, that's 38, and we update the adjacent nodes. So 38 plus 42 is 80, and 38 plus 15 is 53. Okay, now we look at all 4 of these, and we choose the smallest. Don't forget, once you permanently label a node and then update the adjacent arcs, you must then look at the whole network to choose the next smallest temporary label that's not been permanently labelled. In this case, that's F at 42, so that gets a 3 on it with a 42. Update the adjacent nodes. So 42 plus 20 is 62, so that does replace the 75. Don't cross it out. 42 plus 12 is 54, and 42 plus 39 is 81. Okay, now the adjacents are updated. We again look at all of the nodes in the network, and we choose the smallest temporary label with no permanent, which is this one. So that gets a 4 there with a 53. Update the adjacents. 53 plus 17 is 70, and 53 plus 10 is 63. You don't have to write it down because 54 is smaller than that. Cool, so that's all the adjacents updated. Now we choose the smallest one again, which is this one. So that's got a 5 on it with a 54 there. Update the adjacents. 54 plus 14, that's going to be 68, which is smaller than 70, so that replaces that. Again, don't cross off the 70, you will lose a mark. 54 plus 23, that's 77, that is smaller than 81, so that